This lesson is integration by parts. Remember, you can fast forward, pause, or rewind the lesson at any time to view it over. Paste this lesson so that it works for you. Integration by parts uses a little formula. It says the integral of u dv is equal to u times v minus the integral of v du. The key to integration by parts is how you do a setup before you actually try to plug into this formula. So let's look at how that's done. Here's an example. We're going to find the integral of x sine x dx. So what we're going to do here is we're going to try to plug things into this little formula, integration by parts. We're going to identify u as being x, and the rest of the integration, sine of x dx, as being dv. From there, if u equals x, we can take the derivative of both sides and get du equals dx. If dv equals sine x dx, we can take the antiderivative of both sides and get v equals negative cosine x. Now we have all the players. We have a u, we have a dv, we have a u and a v still, and we have b down here. So notice that this du isn't really ever used. It's just these top parts here. So it's uv, this diagonal, u times v minus, actually the du is used, it's the dv that's not used, minus u minus v du. So it's kind of a diagonal down and then back over. So u times v minus v du. U times v minus v du, if you lay it out in this pattern. So let's lay things in there. We've got u, which is x, times v. So u times v is negative cosine x. We always have a minus here, minus the integral of v, which is negative cosine x. Notice this part kind of repeats itself in the middle. The v kind of repeats itself in the middle, and the u's are on the outside. That might be another way to remember how things go here. Times du, which is just dx. Then we simplify and integrate. This is negative x cosine x minus the antiderivative of negative cosine x dx is negative sine of x plus c. Since we don't have points of integration here, we have to add the unknown constant c. We're going to simplify the negative negative here and say plus sine x in the middle. There we go. We've just integrated x sine x dx. Here's another example. I've got the natural log of x dx. I'm going to use the same formula. I'm going to let u equal the natural log of x. That means that dv has to be dx. It's everything else. So once we identify u, dv is everything else that's left in the integral that's not taken up, and that includes the dx. So if we take the derivative of both sides here, we get du equals 1 over x dx. If we take the antiderivative of both sides here, we just get v equals x. Plug into the formula. We need u times v, that's natural log x times x, or x natural log x, minus v, which is x, times du, which is 1 over x dx. X natural log x won't do anything, but x times 1 over x is just 1. And the integral of 1 is just x. And don't forget the plus c, the constant. We're good right there. Another example, t squared e to the t dt. We're going to let u equal t squared. We're going to let e to the t dt then be dv. The derivative of u t squared, u equals t squared, is du equals 2t dt. Notice how this is a simpler thing than this. That's kind of one of the things we're trying to do. Notice dv e to the t, the antiderivative there would just be v equals e to the t. So we'll take u times v, which is t squared times e to the t, minus the integral of v, e to the t, and du, which is 2t d to the t. We can simplify a little bit here. The constant multiple 2 can pass through the integral, come out here. Notice how this t e to the t is just slightly simpler than t squared e to the t. It's still difficult to integrate. So what do? Well, we repeat the process. we're going to use integration by parts on this integral over here. So the rest of it's going to come along for the ride, and we're going to integrate by parts on the integral t e to the t dt. So we'll let u equal t. We'll let dv equal e to the t dt. The derivative of u equals t is du equals dt. The antiderivative of v equals e to the t dt is just v equals e to the t. So we copy down this front part. We have t squared e to the t minus 2 times whatever this integral is. Well, this integral has just been split up into another integration by parts, where I have u times v, or t times e to the t, minus the integral of v, which is e to the t, du, which is dt. This integral we can go ahead and evaluate now. So sometimes it takes more than one iteration through integration by parts to get where we're going. T squared e to the t minus the 2 doesn't change, times the quantity, t squared e to the t, that's just passed through, minus the integral of e to the t is just e to the t, and then plus the constant c. We can go ahead and distribute the negative 2, and we're good right there. Some people wouldn't write a 2 on the c here. They would just say that c is some constant and it's 2 bigger than it was here. And other people would be pretty adamant that we need to see that too. Here's one for you to try. So go ahead and pause the video, give this a try, and when you're ready to check how you're doing, press play. All right, here we go. I let u be e to the x, which means du equals e to the x dx. Then dv has to be everything that's left, the sine x d to the x. The antiderivative of dv is v, the antiderivative of sine x is negative cosine x. Go ahead and plug into the formula. U times v, negative e to the x times cosine x. The negative is actually with the cosine, but when we multiply it together, it can pass through the front. Minus a negative cosine x times e to the x. Now notice this isn't really any better than what we had, because we just basically switched out a sine for a cosine. The negative 1 can pass through, give us a plus. What we're going to do here now is we're going to evaluate again we're going to evaluate this integral using integration by parts. So this time we're going to let u equal e to the x again. Du is e to the x dx. dv is everything that's left, cosine x dx. And we take the antiderivative here. The antiderivative of dv is v. The antiderivative of cosine dx is sine x. And we go ahead and write this out again. So negative e to the x cosine x plus e to the x sine x. This is the new u times v minus the integral sine x times e to the x dx. Notice what happened here. This integral, sine x times e to the x dx, is exactly what we started with. So this thing equals all this minus another one of these. If we're trying to solve for this, trying to figure out what this equals, we should try to get all of that on one side. So what we're going to do is we're going to add this term to the other side. That gives me, let's see, what have I done? All I did was just change the order here so we could see that that's exactly the same, but that was kind of obvious in the line above. We add that to the other side. That gives us 2 of these. So 2 of these integral e to the x sine x dx equals these 2 terms, negative e to the x cosine x plus e to the x sine x. We can divide both sides by 2. That'll put a 1/2 on this side. And we could, if we choose, take out the e to the x. We can factor that to the front. And don't forget the plus c. That has to appear somewhere in the final answer here. So sometimes we'll see this happen where what we're trying to solve for on the left actually reappears on the right. The key there is just add that to the other side and then end up dividing by 2. That was a nasty one for the first U try. That's our learning target for today. I'll see you in class.